For the next problem, we're told that we have a converging lens that has a focal length of 10 centimeters. And then we're asked to locate the images for object distances for these three different distances here, 0.2 meters, 0.1 meter, 0.05 meters. In the problem, it's given to you in centimeters. I just rewrote it because it's a little easier. So we're asked to find the Q values for each of those. Okay, that's what we want. This is the thing we want to find. Then we're also asked to identify whether the image is real or if it's a virtual image. We're asked to identify whether the image is inverted or upright, and we're asked to finally find the magnification of the image. Okay, well, finding Q is the first thing, and that's pretty straightforward. Remember from our formula, 1 over the distance to the image plus 1 over the distance to the object is equal to 1 over the focal length. So we know the focal length, we know the distance to the objects. We want Q. 1 over Q is equal to 1 over F minus 1 over P. That's equal to P minus F over P times F. Q is equal to P times F over P minus F. Okay, and we have these values, we can just plug them in. F is 10 centimeters. P is 20. So we have 10, 20, and these are in centimeters. This is centimeters squared. Over, what was it? P minus F, right? So 20 minus 10 is going to leave you with 10 centimeters. So that leaves us with a value of, this would be 200 over 10. This is going to be 20 centimeters, positive 20 centimeters. Okay, because this value is positive, our Q value is positive, we can identify one of these things that we're asked. For Q greater than 0, we have a real image as opposed to a virtual one. If we want to find the magnification, I keep saying magnetization, which is not right, negative Q over P, all right, so it's going to be negative 20 over, what was P? P was 20 also. These are both in centimeters. Centimeters. Cancel, that means we're going to have negative 1. So what that means, this value of negative 1, is that the image, so if we have a negative value for magnification, that means the image is actually inverted. So it's a real image, it's inverted, so it's upside down, but it's only a value of 1, right? So it's 1 times the image, which means it's the same size, inverted, same size. Okay, then we just repeat that process for each of the 3 cases, right? So for the other 2 cases, we have 10 centimeters and 5 centimeters. So this was PF over P minus F. This is 10 times 10. Is that right? Let me just double check. 10 centimeters and F is 10 centimeters. Okay. 0. Well, that would just blow up. So that means that no image exists. No image exists. Or we could say it in a way, no image is formed. So what happens is we end up getting parallel rays emerging from the lens. So whatever the shape, we have parallel rays coming out this way, as opposed to rays coming here, intersecting and forming an image. Right, so this is the case for B. So for part C, we had 5 centimeters is equal to, what was that, P? So that means, let's see, we're looking for Q. We want to know where the image lies. PF over P minus F. This gives us, if we're staying in centimeters, right? So this is 5 centimeters times 10 centimeters over 5 minus 10. So this is 50 over negative 5, which gives you negative 10 centimeters. And so since Q is less than 0, that means that we have a virtual image. Okay, and magnification. Okay. Negative of negative 10 centimeters over P was 5 centimeters. Units cancel. 10 over 5 is equal to 2. That's a positive 2. So since M is greater than 0, that means we have an upright image. That's 2 times the size because it's value of 2. All right.